Hello everybody, welcome back to another discussion dynamics. Today we will focus on kinetics of rigid bodies. And I believe that today is the last discussion we will talk about this topic. So basically today we are closing this chapter. And plan for today is following two examples. Without further ado, let's dive straight into our discussion. As usually, please take a couple of seconds to read and understand the problem statement before we start our solution. You can use it for dessert. Anyway, let's see what do we have in here. We have two bodies, right? We have block and ring. So let's maybe summarize what we know about them. So what do we know about block? We know that it has mass m. We know that L is given to us. Yes, L is 2 meters. And we also know that moment of inertia about this square, about its center of mass, is 1 divided by 6 ml squared. You can double check that equation in that page with equations or some engineering tables. Okay, what do we know about the ring? We know that its mass is m as well. We know radius and moment of inertia about that ring is, I think, what we proved in last discussion, right? So this will be mr squared. Okay, what else do we know? There is no friction in the system. No friction. And also we know that our system starts from rest. Okay, guys. That's it. I think that problem statement is pretty straightforward. Let's just start our solution. So I will start with FBD for one of these bodies. Let's say block. And KD. So I have to draw a square in here. And this is its center of mass, B. And I have to draw the same square at my KD. No, just kidding. I'm just gonna copy paste it. Haha. Anyway, so now let's show all the forces acting on our block. We have mg in here. And we have two reaction forces coming from these rollers. So this will be one reaction force and the other reaction force. And they have only vertical component, yes? They have no horizontal component because there is no friction in the system. And since we have a reaction on the left and right, let's call them maybe NL from left and NR from right. Okay, is there any other force acting on that system? I think that there will be a force coming from the pin A, right? But we don't know the direction of that force at point A. We will just know it at the very end. So for now, I'm just going to decompose it into these two components, AX and AY. And this is point A. As you can see, the reaction forces in my solutions, they inherit their name after the point they acted. Yeah. So this reaction force acted at point A. That's why I'm going to name it A. Okay, how about our inertia forces? In here we have MABX, MABY, and also our body can rotate. So it will be IB alpha block. Oh, guys, you know what I forgot about? I forgot about what is the question. So they ask us to find these four things. They ask us to find linear and angular acceleration of the block and the ring. So they ask us to find these four vectors: A, B, alpha block. This is not known. They also ask us to find AC and alpha ring. Okay. So anyway, just by looking at that drawing, can you please tell me? Can you please tell me anything about our accelerations? For example, can you tell me something about ABY?
No acceleration in the y.
Exactly, it will be 0. Exactly, this is 0 because this is the trajectory of point B. Trajectory B. Joey, how about our alpha block? Can our block rotate? No. That block has to stay, can only translate. That's why this guy is also 0. Okay, so I think that thanks to Joey, we have like approximately 40% of the problem solved. Yeah, because basically this guy is 0, definitely. This is 0. And I think that Joey told us that that this parameter, this vector, must have such form. Oh, ABX 0, 0. Yeah, so it's more or less 40% of the problem done. Yeah, let's do remaining 60%. Okay, guys, we are done with our FBD and KD. Now let's focus on our EOM. So we must do in here sum of forces in the X direction, sum of forces in the Y direction, and sum of moments about center of mass. In this case, it's point B. And these are our positive direction. This one, and this one. Okay, is there anything interesting happening on the X direction? There is a little bit. We have AX in here. AX, and this is equal to MA BX. How about Y direction? There we have AY plus NL plus NR minus MG. And this is equal to MABY. But you guys told me that this guy is 0. So this will be 0. Okay, now moments about point B. Okay, there are some forces that rotate this body. So one of them is AY times L half, and AY rotates in a positive direction. That's good. And now NL times L half again, but NL, I believe, rotates in the negative direction. So I should put minus in here. And now NR times L half. And it rotates in a positive direction. And this is equal to IB alpha block. But again, you guys told me that this is 0. So that entire equation will be equal to 0. Okay, we are done with FBD and EOM for the block. Now let's focus on the other body. So now FBD for ring. So I'm going to draw a perfect circle, hopefully. Yes, I managed to do it. So this is our ring. And this is our point C. Oops. And let me maybe also copy this. Let me copy this in here so we can see the entire geometry of the body, of the system actually. Okay, what forces act on our ring? Definitely mg. And I think that there will be a reaction force at point A as well. Let me introduce that point A in here. So this angle is 45 degrees. Exactly what we see exactly what we see in this drawing on the right hand side, and point A is in here. And since on our previous FBD, AX and AY have these directions, you can see right now at the top of the screen, on the other FBD, I must just flip their directions, right? So our AY will be pointing this way. And AX will be pointing this way. And I think that there are no other forces acting on that body. So now let's focus on the inertia forces. In here we'll have MACX, MACY, and in here we'll have IC alpha ring. Okay, guys, how about these accelerations? Can you tell me anything about them? Can we guess their values? No. Yeah, unfortunately, all of them are unknown, and they will appear as unknowns in our set of equations. Okay, EOM for the ring. Let me prepare the board. Okay, so in the x direction, we have only AX. And this is equal to MACX. In the y direction, we have minus AY minus MG. And this is equal to MACY. And I think that this reaction force rotates our body. So we will have moment coming from AX and this distance. And this distance is R square root of 2 over 2, right? Because this angle is 45 degrees. So this will be AX R square root of 2 over 2. And this is positive or negative fashion? Positive. And now AY. AY times this distance. And that distance is again R square root of 2 over 2. So in here we will have R square root of 2 over 2. And positive or negative? Positive. So this is equal to IC alpha ring. Okay, guys. We are done with FBD and EOM for both bodies. Are there any questions? I don't see any, so let's recap. Let's recap what we have. Okay, so I'm going to copy and paste these equations here. And I would like to apologize for those of you who are using pen and paper. I will be copying a couple of times today, so just don't get like angry at me, okay? I don't do it in, my intention is not to like, make you angry. So I have these three equations and then the other three equations. Okay, so definitely we have six equations. Now let's see how many unknowns do we have. So definitely all the accelerations are not known. 1, 2, 3, 4. So we have 4 right now. Reaction forces are not known. So 5 and 6. 7, 8. 8 unknowns. Okay, so we need 2 more equations. The question is how to find them. We can, for example, go for the friction law. Yes. However, there is no friction in our system, so this is useless in our problem. Yes. But there are some other ways to come up with more equations. Any propositions? What would you do? Yeah, kinematics. Let's do acceleration analysis. Thank you. Perfect. Let's do for acceleration analysis. Between 2 points. But let's see. Which points shall we choose in here? I think we don't have too much choice. I would go for A and C. C and A. Yeah, axle analysis between C and A. So let's see what do we have in here. AC is equal to AA plus alpha of a certain body times RCA minus omega of a certain body squared RCA. And you know what my question will be. What certain body I should put in that black box? Anybody? Is it block or is it a ring? Yes, it's a ring, exactly. And by the way, our system starts from rest. And we like that because we can eliminate this component. Our omega ring will be 0. Okay, guys. If you are wondering why I went for point C and A, this is why. Because I think that we know what is the acceleration of point A. Acceleration of point A will be exactly the same as acceleration of point B. Do you see that? So in here I will just write ABX 0, 0. And acceleration of point C is what we are fishing for. ACX, ACY, and 0. Please have a look at these equations, these two equations. In here, ACX and ACY occur. So that's why I went for that point as well. I want to find some expressions for these points as well. Okay. So in here I will have 0, 0 alpha ring times this vector, RCA. And RCA, I think it's this vector. And its components are what? I think the components will be r square root of 2 over 2 minus r square root of 2 over 2, 0. Okay, guys, and if you solve this determinant, you will end up with following expression. ABX plus alpha ring r square root of 2 over 2 and minus alpha ring r square root of 2 over 2. And I think that we found our two desired equations. Because if you look at the x and y components in here, you can see that ACX is equal to ABX plus alpha ring r square root of 2 over 2, and ACY is equal to minus alpha ring r square root of 2 over 2. Okay, guys. So we found them. So let's recap for the second time. So I'm going to copy these 6 equations. And I'm just going to complete our set of equations with these two extra ones. Connor, can I ask you to close the door and the other door? That sound on the corridor just pisses me off. Thank you. Thank you, Nicole. Okay, guys. So we have 8 equations and 8 unknowns. And this is solvable. And before we solve it, I think that there are some questions. Yes, James?
I'm just making sure I have my determinants right, or determinant right. Shouldn't the y or the j component be positive as well because it was a positive k crossed with a positive I?
Okay, I will see. Maybe I made a mistake. That happens way often than you think. And you are correct. Of course. Thank you, sir. So guys, I made a mistake. Eliminate this minus. There's no minus here, there's plus in here. Thank you, James. Yeah, there's plus in here and plus in here then, yeah? Cool. Thumbs up. Okay, so anyway, but we have our 8 equations and 8 unknowns, and we have to solve them anyway. So, yeah, but actually the dynamic stops here, right? Dynamic stops here, and the rest is algebra. And by the way, is that course called algebra? No, this course is called dynamics, yes? So I will not solve that set of equations, I will just give you the solution, okay? So basically dynamics stops here. And the rest is algebra. The rest is algebra. Yeah, so basically I solved that yesterday, and this is what I obtained. So I have to provide you solutions for these 8 parameters, right? So it will be ABX, ACY, ACX or ACX, ACY, alpha ring, and also our reaction forces. So AX, AY, and N left and N right. Okay, so this is what I obtained yesterday. This is 1 divided by 7g. This is minus 1 divided by 7g. This is minus 2 divided by 7g. And the alpha ring is minus 2 square root of 2 divided by 7g. We could stop here because they ask us for accelerations, but just for completeness, I will give you the answer to everything, okay? So AX is 1 divided by 7 mg. The other A is minus 6 divided by 7 mg. NL is 1/2 mg. And NR is minus 5 divided by 14 mg. But we care only about these 4 first guys, these guys. And that means that the answer to our problem is following. AB is equal to 1 divided by 7g 0, 0. And alpha block, you guys told me earlier, this is 0. And AC is minus 1 divided by 7g minus 2 divided by 7g 0. And alpha ring is minus 2 square root of 2 divided by 7g k. This is the end of the problem. Are there any questions? I don't see any. So guys, just keep in mind that procedure. FBD and KD for each of the bodies, then equations of motion, then count the number of equations and number of unknowns. You will end up with more unknowns than equations. And then you must find more equations, right? And the dynamics stops there and algebra starts. So what now? Questions or example number 2? Everything is good? Okay, so let's do example number 2. Here it is. Here is example number 2. So please take a couple of seconds to read and understand the problem statement. Okay, so what do we have in here? We again have two bodies. We have disk and bar. Okay, so let's summarize what we know about them. So let's start with maybe disk. About the disk, we know that it has mass m, radius r, and that moment of inertia about point A is 1/2 mr squared. How about bar right now? Bar has mass m, length l, and moment of inertia of each center of mass is 1/12 ml squared. Moreover, we know that system starts from rest, which is good news. Starts from rest. And we also know that there is no slip at this point, and that this surface is frictionless. Okay, I think that again, program statement is pretty straightforward. We can start solving. So let's do the same procedure. FBD for the disk. And KD. So I'm going to draw a perfect circle again. Yeah, check this out. Okay, I'm gonna copy and paste it. And what forces act on our body? I think that we have mg in here, and this is point what? This is point A. We also have normal force and friction force at that point. And that friction force must be horizontal, so I don't know. That maybe it can be pointing this way, I don't know. Let's say that this way. Okay, anything else is acting on our system? There's one more force at pin A. Yes, there is a reaction force here. AX and AY. And that's it. There are no other forces acting on this system. How about inertia forces? In here we have MAAX, MAAY, and also our body can rotate. IA alpha disk. Oh, and by the way, they ask us to find alpha disk. Alpha disk is what they want us to provide. Question to you. Can you tell me something about these accelerations? How about value of AAY? It is 0, exactly. Yeah, this guy is 0, because this is the trajectory of point A. A cannot leave that horizontal surface. Okay, guys, EOM. So let me prepare the board, sum of forces and sum of moments about A. Okay, what happens in the x direction? We have two forces, AX minus TF, and this is equal to MAAX. How about y direction? We have there AY plus N minus MG, and this is equal to MAAY. And now moments. I think that there is only one force rotating our body, which is TF. TF times R, and this is positive in negative fashion, negative. So it will be minus here. And this is equal to IA alpha disk. Okay, guys, we are done with our analysis for the disk. Now let's focus on the bar. FBD for the bar and KD. So now let's see if I can draw that bar. Okay. How about something like that? Something like that and like that. Check this out. I can do it. And this is point C, if I remember. copy, paste. Let me also bring that drawing here. And by the way, this angle is, I believe, 30 degrees. Okay, so what forces act on our bar? mg, definitely. We have a reaction force also at point B, at this point. And that reaction force will be horizontal, because that surface is frictionless. That's why there will be no vertical component there. The reaction at point B is only vertical. How about A? Same story as before. I must take these vectors from the top of the screen and place them here, place them on the other FBD and flip their direction. So in here, our AY will be pointing this way and AX will be pointing this way, I believe. Yes, yes. Okay, and our inertia forces are following: MACX, MACY, and also IC alpha bar. And again, we cannot say anything about these accelerations. They will be there are unknown. EOM. So again, I will just prepare the board before I write down these EOMs. Okay, so in the x direction we have minus AX plus B, and this is equal to MACX. In the y direction we have minus AY minus MG, and this is equal to MACY. And now, oh wow, now these three forces are rotating. Okay, let's start with AX. AX times what distance? I think this distance. And what is this green distance? It would be definitely L12. And now sine or cosine? I think sine 30. Okay, so this will be L. So this will be basically L divided by 4. And positive or negative? Negative. Okay, how about AY? AY times this distance. And this will be L12 cosine 30 degrees. So in here we will have basically L times square root of 3 divided by 4. And positive or negative? Negative. So I have to switch this plus with minus. And the last force is B. And B, the arm there is here. This is the arm. And it's the same as the previous one. I'll have sine 30 degrees. So this will be L divided by 4. And positive or negative? Negative again. Okay, that's all. And this is equal to IC alpha bar. Ooh. Okay, guys, we're done with our FBD and EOM. Let's recap. Unless there are questions, let me know if there are questions. So I'm going to take these three equations. I'm going to put them here. They're too big. Oh, wait a second, but this guy is 0, right? So that dude was 0, so this is 0. So I can also put 0 in here. And I like when my equality signs are aligned. So I'm just going to put stuff in order, okay? Okay. And I think that now I should take these 5 equations and I should put them here. Okay, guys, so we have 6 equations. Let's see how many unknowns do we have. Definitely every single acceleration is not known. So we have 5 of them, 5 unknowns already. 1, 2, 3, 4, 5. Okay, what else? 6, 7, 8, 9, and I think B. So 10 unknowns in this set of equations. Dang, that's not good. 10 unknowns. Okay. What now? Nobody said it will be easy. We're gonna solve this one. Okay, guys. So what are our strategies right now? We must find 4 extra equations. What's the strategy? I see friction in there in that system. Yes? Do you see here? Maybe we can go for a friction law. What do you think? Can I go for a friction law in here? Can I use, for example, such equation? Tf is equal to mu kn. Let me show you the system first, maybe. So this is our system. Do we have, so at this point, do we have kinetic or static friction? Static. So this is useless for us. That equation is useless because we have static friction. So our Tf is definitely somewhere below mu s n. But where it is, I don't know. What is the accurate value of Tf? I don't know. So actually, in this case, we cannot go for any friction law, guys. Our Tf will be obtained once we solve this set of 10 equations to B and 10 unknowns. So yeah, so what's the other strategy? We can go for kinematics again. Yeah, we must do kinematic analysis of our system. So let's do it. Acceleration analysis. Okay, we need to find 4 equations. So let me do acceleration analysis between these 2 points, point E and point A. Okay, AE. So I can write in here AA is equal to AE plus alpha ring times RAE minus omega ring squared RAE. However, system starts on rest, which is great news because we can get rid of this component. Okay, so I think that we know that our trajectory of point A is this. So our AA is this vector. And also we said in the past that acceleration of point E can only have this component because there is no slip at point E. So this AE. I hope that you remember this discussion. So right now I can write in here AAX 0, 0 is equal to 0 AE 0 plus 0, 0 alpha ring times 0 R 0. Because this is the vector, right? This is our vector RAE. Okay, guys, if you solve this determinant, you will end up with following expression: minus alpha ring R AE 0. And if you look at the first component only, you will find our first equation. So our AAX is equal to minus alpha ring R. And this is our first equation. We need to find 3 more. Are there any questions? Okay, so we must do 2 more acceleration analysis, guys. I hope you are ready for that. If you are not, you must prepare yourself for that. Okay, next acceleration analysis will be between B and A. Okay, so in here I can write AB is equal to AA plus alpha of a certain body, and think of that body and tell me what that body is in a second, minus omega of a certain body, RBA. Okay, any volunteers? What should I put in the black box? Look at the picture. Perfect. Yeah, my favorite place actually, bar. But we can talk more about it off camera. Okay, anyway, so what is the trajectory of point B? Trajectory of point B is here. So I think that our B can only have vertical component, right? This will be AB. Okay, so I think that in here I can write 0, AB 0. AA we know, so this will be minus alpha ring R0, 0 plus 0, 0 alpha bar times this vector. And that vector will be green as well. This vector. This is RBA. And the components are following: minus L cosine 30 degrees, L sine 30 degrees. Okay, guys, and if you solve this determinant, you will end up with following expression. You will end up with minus alpha disk R minus 1/2 alpha bar L. And in here you will have minus square root of 3 divided by 2 alpha bar L 0. Okay, and again, the only equation we care about is in the x component. So this equation. The equation on the y component is useless for us. So we found our second equation, which is 0, that is equal to minus alpha disk R minus 1/2 alpha bar L. Okay, 50% of the problem done. We need to go for 2 more equations. And we will obtain them if we run again our acceleration analysis between C and A. And then the problem is solved, guys. So let me write this equation. AC is equal to AA plus alpha bar times RCA minus omega bar squared RCA. And again, I'm really glad that that system starts from rest, because this is 0. And our RCA will be here. It will be orange this time. RCA. And if you solve that equation, maybe you can solve it. ACX, ACY, and 0 is equal to minus alpha ring R 0, 0 plus 0, 0 alpha bar times this vector. And this vector will be minus L1/2 cosine 30 degrees, L1/2 sine 30 degrees, 0. Okay, guys, and if you solve this determinant and if you solve this vector equation, you will end up with following expressions for our ACX and ACY. Here they are. Here they are. They are coming your way. So ACX will be minus alpha disk R minus quarter alpha bar L, and ACY will be minus square root of 3 divided by 4 alpha bar. And this is our third equation and fourth equation. And believe me or not, we just completed this set of 10 equations and 10 unknowns. So let me recap for the final time. So I'm gonna copy these 6 equations. And I'm going to complete them with these 4 blue equations, okay? And this will be the end of our discussion. So I have this first equation here. Then I have this equation. Oops. And then these 2 last equations. Okay, guys, so we have 6 equations that are coming from kinetics analysis, and 4 remaining equations are coming from kinematics analysis. So we have 10 equations and 10 unknowns. Okay, it's 10:50 already. Do you mind staying here for 60 seconds? Is it okay? Thank you, guys. So we have 10 equations and 10 unknowns. Solvable. But I'm not going to take that pleasure from you. You can solve it at home. And the answer I got yesterday is following. They only ask us to find alpha ring, yes? So if you solve it at home, alpha ring is minus 3 square root of 3 divided by 20 G. And the answer, and the vector answer is following. Alpha ring is 0, 0, minus 3 square root of 3 divided by 20 G. So it is clockwise, right? Yeah, it is clockwise. Okay, guys, thank you for today and have a nice weekend.